Okay, and our next session is from the group at Kabbage. Presenting today are Kyle Burke, Head of Data Platform, and Jason Waugh, Head of Reporting and BI. And guys, I'll let you take it away.
Okay, today we're going to talk a little bit about who is Kabbage, to give everyone a little context to why, what we do, and why we migrated to cloud and we're moving to Tableau. So we'll talk about our previous platform, which was an on-prem solution, and how our new platform, which we're calling 3.0, is a complete on cloud or in the cloud platform. Then we'll follow up with our architecture, and it'll, as we kind of review our architecture, it'll make sense why we eventually got to Tableau. And we'll show you a few cool things that we do, just to kind of highlight some of the capabilities that our new platform has. And then after that, Jason's going to follow up and give you some pretty cool examples of some things we're doing with Databricks and Tableau, and he'll show you some of our sample dashboards. Okay, so let's start with who is Kabbage. We were founded in 2011, and the goal was to make lending to small business easier. So we've built a automated platform that basically in less than 10 minutes we will connect to your bank transactions, and we will make a decision on whether or not to give a small business a loan. Over the last few years, we've done over $7 billion in loans to date, and in the last year we did, or in this year we're going to do real close to $3 billion in loans. So we're growing really quickly, and we've actually been we've also received some awards from several different companies, one of them being CNBC. They listed us in their top 50 disruptors across all industries in 2019. We've also been numerous awards for Best Place to Work for 2017, 2019. So we've been recognized by over 40 different publications for either Best Place to Work or innovation. So we really enjoyed being here today to be able to share some of the cool stuff we're doing. We hope other people will be excited and will look us up and see about if we can connect and become partners. The next thing we want to talk about is comparing our old platform to our new platform. Our old platform was kind of our 2.0, and now we're kind of onto our 3.0. Kind of the major differences between them. One was the old platform was a hybrid solution. There was a few pieces of it in the cloud, but most of it was on-prem. Our old platform had a lot of different technologies. My personal team, the data platform team, we're actually responsible for delivering data, and the one issue we were having is that we were servicing so many different technologies that we spent too much time servicing and doing operational type work and not delivering enough data. So the new platform really helps us to focus on delivering data, because that's really the value our team brings. So we cut down on the number of technology we're using, and we've heavily been using Databricks. And we're also using a few things like Akka, which is our streaming platform, and then a few other like Aurora databases and things like that. We're scaling down our SQL Server usage. Actually, one of the issues that we're trying to get through is we're actually at the largest size available in SQL Server and AWS. So we're sort of scrambling a little bit, and our new platform allows us to not to grow as much as we need, as large as we need. We sort of follow Databricks' pattern of saying, like, hey, everyone can kind of have their own cluster. They're not competing for resources, so people can get their work done faster. And ultimately, what ends up happening is because we can kind of shut servers off and on just when they're needed, saving a lot of money. We anticipate to save somewhere between $600,000 and maybe up to $1 million, but probably closer to $600,000 with this new platform. But more importantly, what it's allowing us to do is to get things done faster. We focus on data. People get the resource they need, and when they're done with them, they turn off. So it's been very successful. We have about 100 people that actually hit our data on between data science, data analytics, that are hitting it at any point in time, and they're all over the world. So as you can imagine, that when East Coast is on, the server will be busy, and then we have people in India and people on the West Coast. So it's kind of an up and down usage, so people scale up servers as they need. So we've been finding it very effective, and we didn't have to. Things are effective when people want to get on it. We've told people about it and they are running with it. So we're very excited. The transition has been very smooth. Okay, let's talk real briefly about our new platform. And in our eyes, we break everything up into a real-time system and then a analytical system. So real-time system is basically people on our website. We want to give them fast responses. The analytical system is basically if you want to look across a bunch of users and lots of transactions, things like that, we push it to the data lake. Our old system, we sort of mixed them. We had an EDW, but they were all running on kind of SQL Server, and we had some issues with scale that we were trying to solve. So to talk a little more about the real-time system, basically you're on, people on our website, events are getting posted to Kafka. Both the Akka framework and the Databricks framework are reading those messages. The main thing that we do is we connect to different sources like people's bank account records, and we store those in our transaction store. And also in real time, we calculate metrics off of those. The metrics could be as basic as, what is their balance. As soon as we get done importing their transactions from the bank, then we immediately start doing these aggregations. Right now, in less than a second, we can do these. The previous system, we would have to do it in batch, and it would be an 8-hour process. But the only issue with that is that we weren't using their latest data to decide about their loan. So it was important enough to get their latest data to make a decision on that we kind of built this system out. So this system has been very successful. We're planning on growing it. The latest change we've done is we've actually started putting data science features into our metric store. So that's a metric is just a generic term, but a feature can be a metric also. So we're storing a lot of our features in our runtime metric store, and then we have a process to unload them. So models execute against the real-time system, but we train them against our data lake. So the data lake has all the data. The real-time system, we won't have to store as much. We generally store about 90 days worth of data in there. And then whether it be data science or analytics has many, many years, because all the data is on S3, we don't have to worry about storage anymore. But in our data lake, we basically break it down into a few components. We bring in raw data. We don't give many people or anyone actually access to the raw data because it's kind of hard to use. Basically, we have some inputs that have like thousands of columns, so we try to break it out. So the first thing we kind of do is we have our computational layer, which we use Databricks and mostly EMR a little bit, and we just format it. Kind of the standard Kimball Snowflake design that's been happening for 20 years. We still use a lot of those paradigms. So we have like what we call our data warehouse on the data lake. We also have the metric store that we've talked about. We unload the metric store from production and stick it on here. And then we have some first party that we've cleaned up. First party being data that we generate, and third party being other things, other partners that we connect with. So all of that's in one place. It's all easily connectable. That's where we store it, and then we give people access either through Athena or Databricks. And depending on the use case, a very simple example is we have some account reps that just run some predefined queries once or twice a day. And so what ends up happening, we give them some saved queries in Athena. They bring them up, they run them. That's very similar to what they were experiencing in SQL Server. So it was an easy transition for them. And then anything else, anything that could be complex, or anything where they want to run Python or R, something like that, or they want to schedule something, we basically push them to Databricks. Yeah, I think that covers it. And then the last thing we do is we use Airflow. Airflow is our schedule. The one thing Databricks doesn't do is we have probably 150 jobs running on a daily basis. Airflow gives us the ability to kind of see the dependencies between them. So if we're making a change to an upstream job, we can see all the jobs that are dependent upon that job, and that way we can test all changes. We push them out to production, and it just saves us from some gotchas where before we were using like SQL agent to schedule everything, and it was hard to keep track of, if I change this one job, what actually is going to be impacted. So Airflow is the kind of tool we went with in this platform just to kind of be able to see what dependencies are. So it's been very successful. All right, so let's first talk about the data in a little bit more detail, just to kind of give you guys an idea of the scale that we're talking about. First off, all the data is on S3, so super cheap storage. We have approximately 700 tables that take up about 12 terabytes of data. And we're also at the point now where pretty much all of our reporting and ad hoc analytics are using it. And as I said before, they all access it using Athena Databricks. We did a bunch of testing on this. We actually used some of the indexes that the Delta Lake provides. One of the things we first did is we just did standard Parquet tables, and we had a lot of our tables we were actually going to use in Delta Lake tables just for the speed. One of the interesting tests we did is we had a table with 750 million records in it, and we're trying to see like what would be the performance hitting it with on S3, and we on S3 it took us about 3 seconds to get the response back for a single row of that. We did the same test in a database. It took about 1 second. But because what happens on a SQL server when 100 people are hitting it, a lot of time that the people are spending are waiting for their query to execute. What we end up finding is that the speed is about the same, and a lot of times it's much faster depending on, there may be big jobs running on our SQL server at the time. So if they don't have to wait at all, a lot of times they're finishing up faster. So that's really what's sort of driving this, everyone wanted to get on it is ease of use and speed, and that all the data is in kind of one place. The way we did this, because it only took us about 3 months to release our first version of our data lake. And when we first released it, we had about 500 tables. And what we had done, instead of trying to like individually write application to do a single table, we kind of wrote some generic unloaders that just says go to this table and unload it. And depending on the size of the table, if it was over 1 million records, we would set up some incremental loads, and if it was under 1 million records, we would just flat out replace it. And that allowed us to get a lot of the tables right away. We had a few very specific tables we had to write custom, but over 95% of the tables we unload come directly from this generic unloader. And it's all Spark-based, driven by kind of table metadata that we store. And we kind of set it up where it can be an hourly unload or a daily load, depending on what people ask for. At the moment, we're sort of enhancing it a little bit. We're going to add a PII layer to it where we use the unloader, and then we kind of go through a scrubbing phase. So we're building metadata repository of all the PII data in all our databases, and we'll use that to basically scrub it and remove PII columns and replace them with like a GUID that ties back to some PII. So we're in that process. Once that happens, we'll be able to fully move everything out of our database, all analytics out of our database, and people will only use the data lake for doing analytics. So, and we think, I was just talking to the team about this, is like some of this stuff is pretty cool that we did. So we're probably going to open source that here in the near future. And I think the key that people should look at is partitioning and indexing if you want your queries to be fast. As a general recommendation, I would say, as I mentioned, using the indexes and Delta tables, we had a lot of success. But partitioning is also important for the bigger tables. The tables that are less than 1 million, it doesn't really, we found it doesn't really matter. But when they start getting, 100 million records, things like that, partitioning becomes really important, and not to overdo partitioning. Most of our partitioning is by day. Anything more than that, I've been in cases where we did multiple columns to partition, meaning maybe by day and then some other column, but you end up getting too many partitions, and then Athena and Databricks spends too much time trying to resolve all the partitions, and it actually slows it down. So we've gone to a very basic partitioning just by day, and it's been more than fast enough for us. Okay, next thing I want to spotlight is this deep learning streaming model that we just released about a month ago. It actually was our first deep learning model that we've used in real time at Kabbage. And it was really started as kind of a proof of concept. We were wondering if Databricks could handle the volume, and we're happy to say it can. So basically what this model does is we look at all their balances, people's balances over the last 90 days, and we try to make a prediction of what their balance will be in the next 7 days. So because we're a lending company, what we're trying to do is lend the right amount of money to the people right when they need it. So this is one of our strategies to kind of make that available. So so the idea is if they cross below a threshold that the owner sets, they'll get a notification. They can come in here and they can basically say, hey, I need to take out a loan. So we'll display this nice visualization. This all goes off the metric store that I showed you previously. And it all kind of happens in kind of real time. Interesting enough, it was just a notebook, which is, to me, was when I first started using notebooks, I never thought of using those to release. But I saw a couple other big companies that were actually using notebooks in production. It made me feel a little bit better. And what we found, we built a CI/CD platform that releases Databricks notebooks. So the stability was kind of out of the box with Databricks, which was nice for me. And with this new pipeline, we can iterate very quickly and make improvements. So the other thing to kind of make it useful is the auto retries. Once in a while something will go wrong with it, but we've got it set up in the job, the Databricks job, to automatically retry and use auto scaling. So we do have a situation where sometimes our website's really busy and other times it gets slower. So the nice thing here is that the clusters that we're using scale up and down as we need also. So what for us, the ability to kind of have simple operations was really critical. It's one of the big reasons we use Databricks is that in our organization, we probably have 200 developers, maybe a few more than that, but we only have less than 10 or about 10 DevOps people. So we look for things that, lightens the load on them, and, the features that are kind of built into Databricks allows us to do that. Okay, so that kind of gets us through the architectural piece of this presentation, and now I want to hand it off to Jason. He's going to talk more in detail about how we're leveraging Tableau with Databricks.
Thanks, Kyle. So I'll be talking through how we utilize Databricks and the kind of dashboards that we're building with Tableau. So one of the first things I noticed when I started using Databricks is the ability to mix languages together. So to be able to use SQL, Python, R, and Scala in the same notebook makes Databricks a powerful tool for data preparation. So being able to pull your data in via SQL, then data manipulation via Python, and then some charting via R, etc. And I'm coming from, our reporting stack is 90% SQL and Python, and we had a whole library built out in Python for things like uploading files, Slack alerts, things like that. So that's one of the things we utilize a lot in our Databricks notebooks. So it'll alert us anytime any QA tests fail or anytime like data falls behind, and other notifications so that we can stay ahead of any issues that may arise. And we connect Tableau to Databricks using the simple JDBC connection. And we evaluate quite a few BI tools, but eventually we settled on Tableau for a number of reasons, but one of them being that it had Athena and Databricks support right out the box. And we use a mix of live connections and extracts to Databricks depending on the use case. If it's a small enough data set, we'll use a live connection, but for larger data sets, we'll use extracts. And for complex dashboards, we'll utilize Databricks to prepare various data sets that's going to power the dashboard, and we format it the way we need. We save them as tables, and we'll pull them in for our dashboards. And in some cases, we'll save those as Delta tables for like our account monthly performance or loan monthly performance. We just need to process any new information and not have to reprocess all of that data. And we keep the dashboards up to date with both Databricks and Tableau have their own schedulers, so we make sure our data sets are as up to date as possible so that we present the latest information to our end users. So I wanted to spend time covering some of the dashboards that we publish and share with other employees here at Kabbage. So this first one is an example of our customer dashboard, and we use this to monitor qualification and origination trends over time. We use Databricks to prep the data so that we have one record per month on book for each account and loans. And we make sure we have all the fields that we need for this dashboard. So we pull in any like partner name, the channel they came in, how many loans they took, what is the weighted average APR. We get that all organized first. So then that way, building out the dashboard is easy. And then if there's any fields that we say, oh, we'd also like to see it by this dimension, it makes it very easy to update that in Databricks and say, bring in this other field, and then update the data model in Tableau, and then we can use that as a variable. We like to provide our users with as many controls as possible, and so that they can analyze it in different ways. So here we're giving them control over date ranges. So if they want to see particular vintages, or they want to see how 2018 stacks up, they can apply that date range filter. Then we also utilize parameters, which we utilize parameters in Tableau a lot, and that gives users control to decide, do they want to see the count of qualified accounts, or do they want to see the dollar amount of credit extended? And same thing with loan originations. Do we want to see how many loans were drawn, or do we want to see the dollar originated? And when they select that, the dashboard updates automatically. We also give them control over which stratification variable they want to see. So do you want to see originations broken out by FICO bucket, by risk tier, product type, etc. And lastly, we also in our loans table, since we have each record is loan and month on book combination, we can see like, did this loan originate within 30 days of account creation? If so, they get classified as a new customer. Otherwise, they get classified as returning customers. So that way, our product team can filter and say like, hey, I want to see just new customers. What are origination numbers, or just returning customers, or both? And this is important because we have separate models for whether a new customer or a returning customer. Another dashboard that I want to share with you guys is a dashboard that we built for our policy team. Our policy team is constantly on the go, meeting with different senators, congressmen and women, and they need stats. They need stats quickly. So what Tableau has allowed us, Tableau and Databricks has allowed us, is the ability to provide these dashboards and access to these dashboards from their phone. Traditionally, this was a request that would come in as an engineering ticket. They would say like, hey, these are the metrics that we need. This is the state that we need, and I need it grouped by congressional district, or I need it grouped by county. And a lot of times the metrics were very similar. So we were able to build a policy dashboard for them where they have all of that control at their fingertips. They can see what are the stats at an aggregate level by state, and then also what are the stats by, they can drill down into congressional district or county or state legislative districts. So here, for example, here's a screenshot from the phone, and it shows them choosing Georgia and choosing to look at it by congressional districts. So they can pick this and they can see the exact same stats. They can see how many qualified users we have in each district, what's the credit extended, how much do they have available, number of loans that they drew in 2017, 18, 19, and we can see trends, loans per customer, all of that good stuff. To talk a little bit about the back end of that, we use a PostGIS database to geocode our users daily and store in our data lake. We join our shape files to our customers' locations and say, okay, this user, we look for new users as well as users that have moved, and we say, okay, now they're in this particular congressional district or this census tract. And once it's in our data lake, we can join with all the other data that we have on them, including account details, loan details. We can pull in their credit characteristics, like how many years in business, or what's their annual revenue, their company size. We can get the credit we initially extended them, what's their current credit limit, what's their available line, and then the same statistics by year. What's their weighted average APR for loans they took in 2017-18? How does that compare to 2018? And lastly, this data set is really large, and so we save this as a Tableau extract, and we periodically refresh the data to keep the dashboard up to date, and also to decrease the load time. Any of these dashboards take loading them takes like a couple seconds, whereas our previous result for this, we tried some other BI tools and some other infrastructure, and it would take like 45 seconds to load up the stats just for one particular dimension. So switching to Databricks and Tableau has really sped up the processing time and also sped up how much time it takes for our policy team to pull up the numbers they need. The last example I want to share is from our data science team, and they also use Tableau for model monitoring. And here's an example where we work on cleaning up and publishing data sets for analysis purposes, expose that to our explorers, and have them come up with their own ideas and build dashboards the way they want to see that data. So our model scores are unloaded from our feature store into the data lake for this analysis, and then we use Databricks to prepare that data for dashboarding. And some of the dashboards that they've built include plotting our incoming customer risk tier distributions, saying that trend over time. The example on the right is tracking transition between our new and returning customer models. So what was the incoming risk rating, and now what are they, 3 months down the line, 6 months down the line. And another example is we look at the performance of accounts by risk tier. Is that matching our predictions? What's the revenue? What's our losses and other unit economics related to that particular loan?
Awesome. Okay, that was a great session, guys. A couple of questions. This one, Jason, might be more for you. What are some tips that you have about connecting Tableau and Databricks?
Yeah, so one of the things we've kind of figured out along the way, the Tableau has the ability to create calculated fields on the fly, and they have the ability to create like calculated fields on calculated fields. But one of the things I would suggest is really focusing that data preparation on the Databricks side, just because there's like so much of the power of like using Python, R, SQL. You can really prepare the data and calculate the fields on the Python side, and then that way when you pass it off to Tableau, all you need to do is just drag fields over and say, I want to plot by this variable, filter by this, etc. So yeah, there's definitely a lot of time spent trying to like Google like how to do something in Tableau, but not being able to, but knowing how to do it in Python or something that I'm comfortable with.
Awesome. Okay. And then there's another one here. Kyle, I'll run this to you. Can you talk a little bit about when you decide to use Athena versus Databricks and Delta?
Yeah, sure. Those are typically conversations when we actually were onboarding teams to the new platform. We would ask them, like, what are some of the things that you need? And if they say to us, we just have these queries we want to run, and we don't run them very often, and we're super comfortable in SQL Server, we would generally push them to Athena. And if those conversations sort of started going to the route of like we schedule these things and or we have this complex Python, or we just have some Python we want to run, or some R we want to run, then I would start pushing those people to Databricks. And then if I look at it or if I just look at their queries and they're just, we have some queries that could be hundreds or even thousands of lines of SQL. I generally kind of push those people to Databricks. I feel a little more comfortable that they're gonna have a better experience. Where you can, as people are kind of getting going, if they start getting some errors, and I think it will give you some errors once in a while. And I sort of focused on the best possible user experience. While we had this opportunity, because we were having issues where things were running slow in SQL, and I didn't want to move them from one not good experience to another not good experience. So I was just more cautious, and I would move anything complex in Databricks.
Awesome. Okay. Well, thanks both for a great session, Jason, Kyle. Really, really good stuff.